Okay, good morning, friends. Here we go. We are on the Chapter 8 Practice Test, page 576, 1 through 19, plus throwing in odd, but then throwing in 14, so that we can practice a little law of cosines. We're getting ready to take a quiz, 8.4 through 8.6, and also the whole chapter test, Chapter 8. So this is a good overview of everything you kind of need to know for that upcoming test, and even the quiz for the second half. So let's go ahead and get started. I've selected some problems from the practice test to go over. We're going to start with number 3. Number 3, this is where we are relating the relationships between a right angle and its altitude. And so quickly, we'll just kind of write out what those formulas were just to remind ourselves is that what we've learned is that these, what I call kind of the tented or the roofed dimensions of this triangle is that if you square them, a squared, it's equal to the nearest short end that's being divided times the entire end. Let's go ahead and just write that. Well, actually, you know what? Let's skip this and just do it with the real numbers. In other words, this number here, squared, is equal to the short end, 10, times the entire side, which is 10 plus x. Okay, and probably I think the hardest part of these problems is just remembering these relationships. And there's one for this one here, there's one for z, and then there's one for y. And they're all pretty much the same. So anyway, we'll practice that. So we need to square this. 2 times root 30 squared is equal to the nearest side to it that's being divided in half, 10, times the entire side. So not just x, not just 10, but 10 plus x. So this side squared equals this side plus the entire side. And now we can go ahead and just solve for x. And once we find x, then we're going to have more information to then solve for z and y. So first, when we square this, you can just put that right in your calculator if you need to, but otherwise you can think of it as 2 squared, which is 4, and the square root of 30 squared, which really just gets rid of this radical, so that's just 4 times 30, equals, we'll distribute here, 10 times 10 is 100, plus 10 times x, which is 10x. Okay, 4 times 30 is 120, equals 100 plus 10x. Want to get x by itself, so we're going to, the last thing done to it is adding 100, so we'll subtract 100 from both sides. So that is now 20 equals, this cancels out, 10x. Opposite of multiplying by x, divided by 10 is dividing by 10. That cancels out. And so now we have simply x is equal to 2. That's a nice little solution there. So x is now 2. And really, once you've set that up, then you're going to see these other two go much quicker because we had this unknown here in the bottom. And again, the way that I chose to start there is if I'd started with, say, y, and y squared is equal to this, the two sides multiplied, this times this. And if I'd done y times 10 times x, I would have seen I had two variables. That would not have worked. If I'd started with z, that would have been z squared equals x times x plus 10. And again, I would have two variables in x and z. So this was the only way to start because it only had the one variable, x. So anyway, now let's go ahead and find y. Y, I think, is the easiest. So we have y squared. Go ahead and just do it right here. Y squared equals just the two broken sides multiplied together. 2 times 10. So that's just going to be y squared equals 20. And then the opposite of squaring is square rooting. So y is just equal to the square root of 20. Now we're going to go ahead and just simplify that by breaking it down into its two square roots, square root of 4, or I'm not two square roots, but one of the square roots. Square root of 4 and 4 times 5 is 20. That simplifies to just 2. So we get y is equal to 2 square root 5. Okay, so that then just leaves us with z. Z is just like what we did here. It's going to be z squared equals the nearest piece to it. This corresponded to 10. Z is going to correspond to 2 times the entire length. And it's going to be even easier because now we know what that entire length is. So I'll just do it right here. Z squared equals 2 times the entire length, which is 2 plus 10, 12. So z squared is equal to 24. We're going to square root both sides. And so therefore z is equal to the square root of 24. Same process as before. What square root goes into 24? 4 again. So 4 times 6 is 24. I can square root the 4. So z is equal to 2 square root 6. And I've cam scanned in the solutions to these problems, and you can see that is correct. So we have z is equal to 2 square root 6, x is equal to 2, and y is equal to 2 square root 5. Notice again, if you're struggling to remember the formulas, it's one of these sides equal to this bottom side. The side that's divided into two pieces is always what the squared side is equal to. For y, it's them multiplied together. For these two, which are usually called a and b, it's their nearest side times the entire side. The nearest side times the entire side. Okay, just encourage you to practice those or Zoom chat me if you have particular questions with those. I think this is one of the harder things in the whole chapter, but it might be different for you. All right, number 5. Using special trig triangles to find the ratio. Okay, so the key with the special triangles is they don't give you any sides. This problem asks for the sine of 45. So that means they want you to look at a 45 degree triangle, and they don't give you any dimensions. And that might seem kind of tricky at first. It's more complicated than what we'll see in number 9, except that you just have to remember what the dimensions are for a special triangle. For a 45 90, you remember that the two legs are the same. They're just x, and the hypotenuse is x square root 2. Okay? So x square root 2. Now we can set up a sine ratio. Sine is SOHCAHTOA. SOHCAHTOA. So sine is opposite over hypotenuse. So I'll just pick one of my 45s. Opposite is, so let's go ahead, sine of 45 equals opposite x over hypotenuse x square root 2. Okay? I'll explain it the kind of the slow way, and then I'll show you the fast way in a second if you don't remember, but the x's just simply reduce, and so that means sine of 45 is equal to 1 over the square root of 2. Okay? The faster way is just to ignore x when you first set it up and just realize this is 1x over square root of x, or square root 2 of x, and so you would just write it as 1 over square root of 2. Now this is basically right, except we have to rationalize the denominator, and that means we multiply both sides by the radical on the bottom, and so there we get 1 times the square root of 2 is the square root of 2 over square root of 2 times the square root of 2 is square root of 4, and the square root of 4 is just 2. So the sine of 45 is the square root of 2 over 2. And once you get to maybe algebra 2, but in trig or pre-cal, you'll have these, you're going to find out that you actually have that memorized. But again, the way we got this is by filling in the dimensions of the special triangle. And then I wouldn't even bother with the x's if that confuses you. Again, I would just think of this as 1 and this as root 2x. And if this was a 30, 60, 90 triangle, you would draw your triangle. And again, you'd write in your dimensions like, again, x, 2x, x root 3. And again, I would think of this as 1, 2, root 3. 1, 2, root 3. And so if it's 30, you could just set up the fraction or the ratio according to whichever angle they happen to be asking to. Like number 4, they want 60, and number 6 is a tangent of 60. So tangent, again, you go here and you do opposite over adjacent. think of it as root 3 over 1, and you'll see the answer is root 3. So the key with the special triangles is to fill in the dimensions. And then I would just basically erase the x's, except that's not 0, that's 1. Okay, again, ask for help if you want more with those. Number 9 is just your bread and butter trig problem. They've given you an angle, they've given you a side, and they've asked you to find side FG. Side FG, I'm going to call that side H, because it's across from angle H. Okay, so we look at 34 and we look at our two sides, and what do we have? SOHCAHTOA. We have the opposite over the adjacent. Nothing involving the hypotenuse. So that is our friend tangent. So tangent of 34 equals the opposite, 6.1, over H. All right, now if you've been following along, like I'm sure you have, praise the Lord, if we have the variable in the bottom, the way you'd algebraically solve this is the H gets multiplied over, and then we would divide the tangent 34 back in. So skipping that step, because this is, hopefully we've been practicing that, it's H is simply 6.1 over tangent 34. And so that's our answer. But in order to get the numerical answer, to find it when you're taking this on the quizzes, you need to find it, you need to put it into your handy dandy calculator. Okay, and so we just plug that in, 6.1 divided by tangent of 34, and we get 9.04. They want this rounded to the nearest hundredth, so I'm going to do the 9.04 as my complete answer. 9.04. Since they're units, we don't want to be naked, at least not on a test. 9.04 inches. Okay, and that's reasonable. The other side is 6, that being 9. That you should always kind of say, does my answer seem in proportion to the triangle I'm solving? Yes, it does. That seems reasonable. Okay, and then we're just going to apply this same principle to a word problem in number 11, angle of depression. An observer at the top of a skyscraper, there's this little guy. I don't know why he's up on the building staring down at a tour bus. He's looking down at an angle of depression, so he's looking down at the bus at an angle of depression, so that's down here from horizontal. Okay, so that's right here. His angle of depression is, says it's 61 degrees. And the building is 910 feet tall. So depending on how you want to do this, you could draw this as your triangle. Okay, maybe that's what we'll do. Or you could draw your triangle here. In some ways it's simpler if you draw your triangle here, and actually maybe I'll just do it that way to show you the easiest way. Why not? So he's looking down at 61 degrees at our tour bus, and it says the building is 910 feet tall. So that translates over to here, because that's still just the height. So here's our triangle, 61 degrees, and we are trying to find the horizontal distance between the building and this awesome tour bus. Okay, so that's x, which for our triangle translates to this distance right here. So this is the key step, I think, because if you can do number 9, these should be no problem, other than you might have trouble drawing the picture. Remember, angle of depression comes down from horizontal. Don't put it here. No, 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 no. And then you can reconstruct your triangle from the information. Height of the building, horizontal distance. We take a look at our SOHCAHTOA. We start our chant. I know you're doing that every day, morning and night. SOHCAHTOA. We have the opposite and the adjacent again, no hypotenuse. And so bring out our old friend tangent. Tangent of 61 is equal to the opposite, 910, over the adjacent, x. So notice this is exactly like problem 9. And so we're going to solve it the exact same way. X must then be 910 divided by tangent 61. Oops, I'm slipping off the camera there, sorry. Okay. Let's get our calculator here. Again, showing your work. If you ever mess up in the calculator step, if I see that, you're going to get full credit, actually, if all I know is that you messed it up on the calculator. So being neat, notice I'm trying to model neatness here, and cam scanning working can get you some extra points on these quizzes and tests. All right, divided by tangent 61 504.4. We are rounding in the problem to the nearest foot, so we're going to just round that off to 504 feet. So that bus is 504 feet away from the building. I know you really wanted to know that, and now we do. Okay, x 504 feet. Okay, so those are problems 3, 5, 9, and 11. I'm just going to switch paper here, and we're going to do a couple more. Practice our law of sines, cosines, and then our vectors. Okay, here we go. So we've got two problems here in which we have to solve a triangle. Notice the transition that's happened now is in the last two problems, 9 and 11, we had right triangles, and that's where we use our basic SOHCAHTOA whenever you have a right triangle. However, 13 and 14, we have non-right triangles, so you cannot use SOHCAHTOA, but you can use the law of sines and the law of cosines accordingly. And so the key is for knowing when to use which, and as I've tried to emphasize, the key, start with the law of sines. I think it's a lot simpler than cosines. And the key is, do you have a corresponding angle and its side? So do I have an angle and the side across from it? As soon as I see that I have that in this problem, I'm saying law of sines. We are trying to find in number 13, we're trying to find RS. RS, that's nice and convenient because that's across from the angle they've already given us, though we could find R very easily because these all add up to 180. But we're trying to basically find side T. Okay, so we write our proportion based on our corresponding sides and angles. So sine of 35 divided by the opposite leg of 11 equals the other angle I know, sine of 108, over now the leg I do not know, T. Okay, and we solve our proportions by cross multiplying. Again, if you're following along, hopefully this is beginning to feel a little routine, but that's okay. If not, glad you're making an effort. So we have 11 times sine 108 equals sine 35 times T. So again, this is times T. I want to get T by itself, so I'm going to undo that by dividing by sine of 35. I always write out all this before I put in the decimal form, but you can work out the decimals ahead of time if you want and just work with them. Because that's then going to cancel out, and we now know that T, oops, that's not a T, T is equal to 11 times sine 108 divided by sine 35. Notice if you ever want to get shortcut, you start working really quickly on proportions, it's just cross multiply and divide. You multiply the two across that you know and then divide by this third thing. So you don't even have to necessarily go as slow as this step here. You think, okay, I'm going to multiply these two and divide by that, which is what we have here. Multiply, cross multiplied and divided. And again, calculator time, because I don't know that off the top of my head. Maybe you do. Congratulations if you do. 11 times sine 108. I'm going to go ahead and hit enter because calculators, if you don't have a graphing one, are kind of weird. All right, so that's the top part divided by sine 35. And we get 18.23. We're rounding to the nearest tenth, so that is 18.2. Victory in Jesus. All right. T equals, whoops, I'm kind of bleeding into my next problem. I'll put it over here. T equals, oh, I did it again. T equals 18.2. There she is. Alrighty, 18.2. And again, the other side was 11 and 18. That's reasonable. If I'm getting a side of like 57 and the other side's 11, that might be a little bit of a problem. So that's the law of sines. And again, we can use it because we have the opposite side and angle. We're given that information. Whereas on 14, and the reason I threw in 14 as the only even problem is because I wanted to make sure on this practice test you practice the law of cosines. Because notice, I don't know any of the angles. And so I do not have any of those pairs. So this law of sines will not work for number 14. We have to use the good old law of cosines. Okay? And again, the other clue is side, side, side. Now that's when side or side, side or side angle side is when you will have to use the law of cosines. And so the law of cosines, let's just write it out since it's always good to review what that is. I made a mess right there. It is c squared, the side I might be looking for, equals the other two sides squared plus squared, equals those same two sides multiplied. Oops, sorry. Minus, getting sloppy, minus 2 times those sides multiplied, 2ab, cosine the angle I might be looking for. Okay, and so the real key here is, again, that C represents either the side or that corresponding angle that you're looking for. Obviously, we're not going to need the side. We know all the sides. So we must be looking for an angle. And yes, they're asking for angle M. So that means M is my key angle. And that means that C, the important part to setting this up is that C is the side across from the angle I am trying to find. So if I want angle M, then I'm using 7 as my C. And so we can start to just fill things in. 7 squared equals, and now it's just a matter of not messing up the arithmetic. 10 squared plus 15 squared minus 2 times 10 times 15 cosine, and now I'm looking for M, so I'm going to put an M in there. Cosine M. Alrighty, now it's good old arithmetic. 7 squared is 49. And hopefully you've seen this, but you will get much faster at this. I go slow and steady because I'm doing it as a video, but you can crunch these numbers pretty quickly. 10 squared is 100. 15 squared is 225. Minus 2 times 10 times 15. Think of that as 150 times 2, 300. Cosine M. Okay, the big no-no, do not subtract 300 from these two. Watch out, watch out, watch out, watch out, watch out. Okay, number one mistake I see in solving these. So we get 49 equals 325 minus 300 cosine M. Because again, cosine M is being multiplied by negative 300, so we can't just combine these two numbers. Instead, we're going to think of this, it's basically like 3 minus 3x. So the first thing we have to do is subtract this, minus 325 from both sides. You're going to get a negative number, have no fear. So 49 minus 325 is negative 276 equals negative 300 cosine M, because this canceled out here. And now you've basically got a situation where you have like 2 equals 3x. So to get x by itself, what I want to find, I need to divide by negative 300. Okay, that cancels out. And so if I do 276, you can leave it that way. I'm going to get the decimal. 276 divided by 300, 0.92. And they're both negative, so that's why it came out positive. So 0.92 equals cosine M. Okay, so we have a ratio, and we're trying to find an angle. That's where we're going to need to use to get M by itself. We're going to need to use inverse cosine. Inverse cosine. So that cancels out, and I just get M equals the inverse cosine of 0.92. Let's find out. I'm so excited. Inverse cosine of 0.92 equals something that looks like a plausible degree, 23 degrees. And we're rounding to the nearest degree, so that's what we're going to leave it as, 23 degrees. So M is 23 degrees. So notice, a lot of arithmetic there, used up a lot of the space. I won't need much for these two problems, but be careful. Law of cosines. Put some effort into it, and be careful and practice it. Watch this again. Go back and see sections 8.5, or also the ready to go on. Do another law of cosines problem in that video. But again, if you've done it enough, you're going to get more comfortable with the process. And again, the neatness of the work really helps you to avoid arithmetic errors. Okay, and we had to use that because we did not have the corresponding side and angle. All right, that takes us to vectors, which after all that, the vectors are like a breath of fresh air, easy peasy, lemon squeezy. So for number 17, we have to draw the vector and get its magnitude. And if you remember, the magnitude is simply the length of the line, the length of the vector, the strength of it, the magnitude of it, the amount, the quantity. So it says to graph it, so we'll assume we get points for graphing it. So we go over 2. Oh, I'm going to barely have room for this. Over 2 and down 3. So that's 1, 2, 1, 2, 3. So this vector is down, headed this way, southeast. All right, and so if we need the magnitude, that's just the hypotenuse. It's just the hypotenuse. And that's why if on the quizzes you're not going to have to draw this. You can do this very quickly without even sketching this if you don't want to. Because all we have is a right triangle with sides 2 and 3. And we need to find the hypotenuse, which is a squared plus b squared equals c squared. So we just have 2 squared plus 3 squared equals c squared. 4 plus 9 equals c squared. That's 13 equals c squared. Okay, square root both sides. So the magnitude is the square root of 13. And I think they want us to actually calculate that. That's why we're using our calculators. Somewhere around 3, because 3 times 3 is 9. 4 times 4 is too big, would be 16. So it's 3 something. So we get our square root of 13. And that's 3.6. Round it to the nearest tenth, it says. 3.6. That's how we know they want us to actually find it. C is approximately 3.6. So that vector, whatever it is moving, which would be southeast, is going at a magnitude of 3.6 something. Again, notice, sorry, the work is kind of bleeding into each other. But we're almost done. Number 19, if you're still with me. This is now we're trying to find the direction of the vector. So here we found the magnitude, which is the length of the line. We could do that here, but we're not doing. They didn't ask us to do it. They want us to find the direction, which means they want us to find the angle at which it is moving. So I'll just draw it to demonstrate it, what we're doing exactly. We've got our vector of 4, 1. So that's 1, 2, 3, 4. Because again, this is like an x and a y. X is horizontal, y is vertical. A little neater here. So we go over 4 and up 1. 1, 2, 3, 4, up 1. So this vector is headed northeast. And so I could square these and do the whole Pythagoras thing, and I'd know the vector here, which they might ask for. Or the direction means, and again, I'm just going to create my triangle. It means they're trying to find this angle. It's real small in there. So I'm trying to find this little angle. I should expect something kind of small, because look how tight and acute that angle is. So cute. So this is 4, and this is 1, and that angle. And if you remember if you've been practicing this, since vectors are always the opposite and the adjacent side, you're always going to use tangent pretty much for these problems. So this angle would be opposite over adjacent, or the tangent of the angle I do not know, which I like to use theta when I don't know an angle, my Pokeball, is the opposite 1 over adjacent 4. Okay, so now I'm just like back at this problem where I knew the ratio and I didn't know my angle, and so the answer is to do the inverse. I need to undo the tangent, so inverse tangent to figure out what the angle must be. The opposite step to get that theta variable alone. Because that cancels out, and I just get theta is equal to whatever the inverse tangent of 1/4 is. Let's find out. Inverse tangent of 1 divided by 4. 14.0, we're rounding to the nearest degree, so that's just 14 degrees. And again, I said we expected it to be small because of how acute it is. 14 degrees, yep, makes sense. So there it is, points in the bank. Theta is 14 degrees. And then depending on how tricky the problem was, if we had to add our cardinal directions of north, south, east, and west, we would say, well, that is headed east, but 14 degrees to the north of east. So we would say east, 14 degrees north. There might be a couple problems on the test, or a problem on the test where you have to be that specific. Okay, well, here is your Chapter 8 practice test. I'll put those both there in case you want to freeze the work. Didn't do every single problem, but the ones I didn't do are just like any of the ones I did here. So again, hope you're doing well. Hope you reach out and ask for help if you need it. Have a great day.